Good morning, class. Now that we have studied the basics of energy waves, we're now going to move into looking at how energy waves interact with mediums and how they interact with each other. So this Part 4 notes is going to cover two of the interactions, and that is both reflection and refraction. Part 5 notes will then cover diffraction and interference. Reflection. Reflection is when a wave reaches the end of its medium or hits a different medium through which it cannot travel. Therefore, it bounces back. In your textbook, I like how it shows water in a swimming pool reflecting off of the wall, and also sound waves bouncing back, which create echoes. And I would like you to look in your textbook at both of those examples and make sure you understand how those work. I also really want you to pay attention to these two diagrams down here at the bottom, and they are also on your notes. It is real important for you to know all of the vocabulary here. So this right here, this plane mirror, so this mirror is the medium that the energy waves cannot travel through, and so therefore we have this energy wave moving in, and we call this energy wave the the incident ray, or this can also be called incident wave. So this energy wave moving again is called the incident wave. The angle that it moves in is called the angle of incidence, and how we find that angle is we create a perpendicular line from the barrier medium, and this is called the normal. And from the normal, we find the angle from there to the incident ray, and that is known as the angle of incidence. I remember this vocabulary term, both the incident wave and the incident angle of incidence, is because it is the incoming wave, and so therefore it also be the angle of incidence. Now, once that hits the medium, it will bounce off at the same angle that it came in. So if we measure again from the normal to the area where the reflected wave is traveling away from the barrier, then that would be your angle of reflection. A common mistake that students make when they're measuring their angles is they measure from the barrier medium to the incident ray or to the reflected ray. This is not where you want to measure from. Okay, so you always want to measure from that perpendicular line from the barrier medium. Okay, in this circumstance, the plane mirror is the barrier medium. Now, on this one, it shows the same thing, but here we've got a vertical. We've got a vertical barrier medium. It's her sunglasses. As you know, sunglasses can block some UV light depending on what kind of sunglasses they have. And so you have an incoming wave, incident wave, I prefer it be called. You've got a reflected wave, okay? If I want to measure, I draw that perpendicular line called the normal, and I measure the angle of incidence, which will be equal to the angle of reflection. So again, you really need to have a good understanding of all of those vocabulary terms and be able to label diagrams as well as measure the angles, which we'll practice in class. Alright, so now we're going to move on. I clicked on the online link. I want you to look at how sound waves are going to bounce off the different types of surfaces that are in this room. So if we click on the different speakers, you can kind of see what happens. And here we have a sound wave sent out, and you can tell that this curved surface, it's also a solid surface, has made an echo because the sound waves did return back towards the speaker, but it wasn't much of an echo. These sound waves were weaker. So let's click on that one more time so you can see that. Yeah. Okay. Here we have a flat surface wall, so it is a solid flat surface, and you can see that this echo did occur, and it was much stronger of an echo than the curved surface. In fact, there was more bending of the sound waves and spreading out of the sound waves during that echo. And here we have a speaker that is going to blare its music or sounds towards a jagged surface, and you can tell that because of where the sound waves are hitting, there is more than one echo, or the direction of the echo changes depending on where the sound wave hits. Last one, we have a porous surface. So this is not a solid surface. This is a surface that has holes in it, and when you have a sound that moves towards it, it does not echo. So of any of these wall surfaces or ceiling surfaces, the porous surface is going to create the least sound reflection. Now, one thing that's kind of cool is, the HVAC building that was built out in the courtyard. It houses the equipment that helps cool and heat our buildings. And what's kind of neat is that the ceiling actually looks like this type of surface. And so when those machines are running and they're creating really loud sound waves, the sound that hits the ceiling is more absorbed, and it doesn't echo and kind of carry on that sound within the building, making it really loud, and also making it louder outside of the building. So it helps dampen the sound by absorbing it. All right, so now we're going to be moving on to a little bit more information about reflection. And this is basically just going over in words what we just showed you in a picture on the last screen. So the incoming wave is called the incident wave, and it's the original energy wave. Wave or ray, it doesn't matter which one you say. Now that wave, the incident wave, always bounces back on a barrier medium. That wave that bounces back is called the reflective wave or ray. The angle that the incoming or incident wave bounces onto the barrier surface is called the angle of incidence. Again, I remember this because the wave that's coming in is called the incident wave, and the angle of incidence measures the angle from the normal to that wave. So when the sound wave, incident wave, bounces off the barrier medium, it creates another angle called angle of reflection between the reflective wave and the normal. Don't forget that is important when you're trying to figure out the angles that you draw that normal line in. The normal is 90 degrees or perpendicular to the surface or barrier medium that the wave is bouncing off. All right, so now we're going to talk about the law of reflection. The law of reflection simply states the angle of incident is equal to the angle of reflection, which we also talked about on that first screen that showed the two different diagrams of a reflected wave. And here's a simple example. If you've ever watched billiards, it's kind of interesting how accurate they can be when hitting a cue ball and being able to tell exactly which ball and to hit, and they even know the speed that they should hit it in to get the right ball and only the right ball in that pocket. So again, here you have a barrier medium, which here they've used a mirror, but if we just talk about the side of the pool table, you've got a normal that's here. And so this angle is going to be equal to this angle. And so they know if they hit this ball here, it's going to bounce perfectly and hit this ball here if they use the right speed. Another example that I like to think of, and we also kind of looked at this when we went to that online link and you saw the jagged surface. Here we're going to use water as the jagged surface, and we have the sun shining down on that water. And I'm going to show the sunlight hitting the water at two different angles. So here we have the water hitting, and I'm going to try to draw in my medium, my barrier medium. So it's kind of hitting on a surface like this. And so if I draw that normal line in, the normal line is going to be here. And so I know that if this is my incident wave coming in, I've got my angle here, and that means that my angle over here will be about the same, or it will be the same, which it doesn't look great in my drawing, but you know how terrible of an artist I can be. But these two angles would be the same, so this would be the reflective wave off of that water. Now, if the light hit over here, okay, what's going to happen is now we've got the surface that the barrier medium is here. And so we've got a normal that's more coming on this side. And so the reflective wave may actually come on this side of the normal, which would be the opposite. So when you've got an uneven surface like water, this law still applies. The angle of incident will equal the angle of reflection, but it doesn't mean that all of the energy waves will bounce back in the same direction that they came from. They may bounce differently depending on the angles. The last thing we're going to talk about today is refraction, and I'm going to kind of compare refraction to reflection as we discuss it. Refraction is when an energy wave is able to move through a new medium. So instead of reflection, where you would have a bouncing off of an energy wave, this time it actually is able to move into the medium. However, you can see that there is some bending that takes place once it enters into that new medium. Okay? This is called refraction. So the bending of an energy wave when it enters a new medium is called refraction. In your textbook, it uses two examples. It talks about a skateboarder. You're skateboarding along, you hit some grass, and therefore this would be the new medium, this would be the grass. And what happens is the wheels that get caught on the grass, you're going to curve into the grass, and it's going to slow down your motion. And so therefore it changes your angle that you were moving in. Also a prism rainbow. It shows you an example of that and how light is often refracted through objects. So again, talking about movement of something and thinking about this as an energy wave, here we've got a car traveling and it hits a rough area on the side of the road. Those wheels are going to get slowed down here, and therefore it's going to change the direction of the car. And this is exactly what refraction of an energy wave does. When there is a substance that is different in some way from the substance that the energy wave was traveling through, it could be temperature, density, any kind, elasticity, any kind of factor that affects changes the medium, it will also change the way the energy is moving through. And so therefore we've got some kind of substance that is causing the energy wave to slow down, and that therefore it is a bent energy wave moving in. And you see examples of this all the time. We're going to look at some demos in class that have to do with refraction. Now here are two examples, and we'll look up some similar things in class. And this is showing you how light bends. So it's shining it through glass. So here it's traveling through air, but here it's traveling through glass, and then it's going back into air. So we have more than one transition here to different mediums, and therefore the light is bent. Also, we have a glass that we're looking at here, and this is showing, okay, now we're looking at the straw through air, now we're looking at it through glass, now we're looking at it through water. And so because of the three different mediums that we're looking through, it just looks bent due to the way the light is traveling through each one of those three mediums. Now, last, what I would like you to do is answer the questions on the bottom of your notes and make sure that you understand the answers. You can use your notes to help you answer those. We also will be doing some demos in class, and I expect to see some information about the demos, whether they are about reflection or refraction, and what did you see during them and what did you learn from them.